Good afternoon, class. In this recording, we will talk about inverse trigonometric functions. And the first half, we will talk about some basic techniques on how to evaluate differentials involving inverse trigonometric functions. Then on the second half, we will tackle a few applications of this form of derivation. So makita nato diri class that there are also six basic differentiation formulas or rules involving inverse trigonometric functions. So, in comparison, ang ordinary nga trigonometric functions would still involve trigonometric identities sa ilang derivation. But for inverse trigonometric functions, ang iyahang derivation after you have evaluated the derivative kay in terms of u na lang, u as a function. So dili na ta makakita og kuan trigonometric identity in terms of u as a function f of x. So to revisit, mo ni siya ang katong sa ordinary nga trigonometric functions. So mapansin ninyo na in terms of trig identities gyapon ang resulting na form, which is unlike this one. So natay mga pares-pares dere. Si arc sine or arc cos, then we have si arc tan and arc cotangent, then si arc sec and arc cosecant. So ang inverse man na siya ang kanang na ay negative 1 exponent or arc sine sa iyang name. So inana ang notation sa inverse trigonometric functions. So kaning mga pares-pares dare na siya'y proof dare sa following the formulas. So ang proof for the arc sine, more or less the same process with arc cosine, only that it is negative. So maro na ang ilang kalahian class. So with that, mas dali siya timan-an kumpara sa ordinary nga trigonometric identities or trigonometric functions. So mo ni siya number 1, number 2, then number 3. So just in case na makalimot mo sa differentiation formulas, we have this derivation or proof na gihatag. So basically ang atong u is in terms of the trigonometric function mo ni siya. Then kung i-derive na to si sin y, makaka-obtain ta og du over dx is equal to cosine y dy over dx, which is kaning nasa 1.3. Then to obtain dy over dx, we need to transpose cosine y to the other side of the equation. Hence we have equation 1.4. Then ang ato ang derivation sa pagkuha sa mga equivalent na kana bitang trigonometric identities for specifically for this one is kani, and kana siya class gikan na siya dito sa sine squared y plus cosine squared y is equal to 1. So diyan na siya gikan, isa na siya sa mga pinaka basic na trigonometric identity. So, ibalik na to na siya, ay i-substitute na to na siya dari sa cosine y in place of cosine y. So, we have square root of 1 minus sine squared y. Then, to recall, we have u is equal to sine y. Mo na nanatay 1 over square root of 1 minus u squared. So, kana siya class, dali lang na siya timanan if we familiarize ourselves with the trigonometric identities. So, at this point sa differential calculus, it is quite given na familiar na mo daan kini agi naman mo theoretically og geometry class. So, let's proceed with sample problems. Number 1 is pretty much basic. We have u is equal to 3x. So, i-substitute na to siya dito sa dy over dx. For arc sine, we have 1 over square root of 1 minus u squared du over dx. Muna siya ang nahitabo dari. So, i-substitute na to siya. Then, the rest of the process is just simplification. Then, we have the final answer in factored form. So, it is important class na ang atong final answer should be in factored form because we want you to be familiar or to be upskilled in terms of factoring out complex equations. So diha nato makita class na nanadyo mo natunan or sakto na ang inyong knowledge sa mathematics. Second example, we have arctangent. So atong u this time is equal to x over 4. So kung i-derive na to na siya, mahimo na siyang ang d over dx niya is kanang quotient rule. So, hi sir. Again class, ang derivation ani niya ang mahulog nga asa man to, du over dx is v du minus u dv over v squared. So you have 4 tapos ang derivative sa x is 1 minus x tapos ang derivative sa 4 is 0. Derivative of a constant is 0 times 4 squared. So we have 1/4. So mana siya ang nahitabo dari nga portion. Mana siya. Kani siya is simply gi-substitute lang siya sa sa ato ang given na formula. So we have 1/4, then simplification na ni siya dari from then. And our answer is this one. Then sa third na example, it involves arc cosecant. Atong u dari is 4x. Then we will need to use this one. So we have dy over dx is equal to negative 1 over u square root of u squared minus 1 du over dx. So mana siya nahitabo dari, gi-substitute siya. Then simplification. Then atong final answer in factored form. Then, fourth example, we have negative sign or arc sign, square root of 1 minus x squared. So, itong u dari is kaning tibok square root of 1 minus x squared. So, for evaluating du over dx, pwede na to siya i-evaluate via power rule, in which ang term na 1 minus x squared is in the exponent of 1/2. So, 1/2, 1 minus x squared, negative 1/2 because 1/2 minus 1. Then, ang derivative na 2x. So, mag-cancel ang 2. We have na siya ang nahitabo dari. We have x over square root of 1 minus x squared. So, kani siya class, mag-cancel ang square root. Then, this from this point is just a matter of simplification. Then, we have our answer in factored form. Then, for arc cotangent, medyo nagka-complex ng atong given but nothing to worry about. Ang u na to is 1 plus x over 1 minus x. So, para ma-integrate, ma-derive siya, we would use quotient rule. So, mana siya ang nahitabo ani nga portion. Then, kani siya nga portion pod is just gikopy lang siya gikan dito sa general formula, which is katong dy dx sa arc cotangent, which is 1 over negative 1 siya, negative over 1 plus u squared du over dx. So, mana siya. So, simplification lang ni siya, class. Then, ang atong answer is kanina, very short na, or the simplest form of the answer. Then, ang ato ang sixth example involves two inverse trigonometric functions. So, we have to use quotient rule first. So, manong taas kay siya sa sinugdanan. Then, from here, it's just a matter of simplification na lang. Ang nahitabo sa kaninga example class is dari ra nga portion nag-evaluate sa derivative sa inverse trigonometric, which is kaning 2 minus 3 arctan x. Kanilang na portion. Then the rest kay kuan na siya, quotient rule simplification. Then atong answer, which is obviously factored out na. So, mana siya itong gusto nga final answer na makuha, class. So, mana siya for the sample problems. Then, we have applications. So, natay tulo ka applications. we have first tangents and normals. So with that we mean a tangent line and normal line sa given curve. Then second one is optimization scenarios or problems which mainly involves maxima and minima. So if this is not familiar with you yet, ginagamit na to ang derivation to evaluate the maximum value or the minimum value that the function, the curve yields. So man na siya ang idea or tumong sa optimization. Then ang third application would be related rates. So kung mulihok ang point A sa isa ka butang, mulihok po ang iyang corresponding na point B. So mana siya parehas sa movement sa sun o movement sa ato ang shadow relative to the sun. So kana siya kanang idea sa related rates. Now, first example dari is kaning tangents and normals. So the problem wants us to find the tangent line and the normal line. With that, ang equations ana na line to the graph of y is equal to arc cotangent x, specifically at point x plus 1 is equal to 0. So required na to pangitaan ng tangent line and ang normal line, both in general form of the equation and slope-intercept form. So x plus 1 is equal to 0. So we have the point x is equal to negative 1. Then we have y is equal to arc cotangent x. So kung i-substitute na to ang x with negative 1, we can obtain the value 3 pi over 4. So we have the point at this specific point, negative 1 comma 3 pi over 4. So this is in the form of polar coordinates, or yeah. So we would then proceed to derive arc cotangent. So man ni siya ang naitabo dari. So ang derivative sa arc, ang derivative sa y or ang derivative sa equation sa atong curve is our slope of the tangent line, which is MTL. Muna siya. Then igo lang na to gi-substitute ang point, ang coordinates. Then para makuha ang ang slope sa normal line, we have MTL is equal to negative 1 over NL din dapat. So para lang na makanang perpendicular lang na sila nga lines to each other. So now that we have both the tangent, the slope of the tangent line and the slope of the normal line, we can obtain the equations. So we have, first off, for tangent lines. So mani siya ang point slope form. So i-substitute lang nato ang values ni x sub 1 o y sub 1. Then ang m. Tapos makuha na nimo both ang general equation and ang slope-intercept form. Then for normal line at that same point, since na naman tayo point tapos na napud tayo slope, value sa slope, makuha na po nato ang general equation form and slope-intercept form. So dili kay siya ingon anak kalabad. Ang second na sample problem is about optimization problem. So a man is viewing a large oil painting which is on display at a gallery. So mani siya ang painting kanya kong ginaguhit. So side view. The top of the painting is 9 meters from the floor, while its bottom is 3 meters above the floor. So mani. In order to have the best view of the painting, the angle subtended by the painting must be a maximum, and that the man's eyes are 2 meters above the ground. So mani siya ang eyes, mata. So naay specific na position ang atong mata na siya specific angle of view in order to see the best view of the painting. So ang atong optimization problem dere is how to find the best view of the painting given that the man's eyes should be kaning a distance should be 2 meters. So this is just a matter of how far from the wall should the man stand, or in this case ang ato ang x. Unsa dapat kalayo ang tao magtindog from the wall where the painting is mounted. So we can come up with a diagram first. So muna siya ang diagram, and diagram is a must na i-provide ninyo sa inyong mga quizzes or exams. So kailangan ninyo siya drawingon. And kung mag-drawing mo class, make it as clear as possible. So sa pag-obtain na to or pag-drawing na to sa diagram, makita mas ma-appreciate na to ang problem o ang mga variables na ato ang gusto i-solve. So we have angles alpha, beta, and theta. So ang angle na involved sa kanabitang viewing angle sa painting is ang beta, which is kani. Therefore, mo na siya nga angle class or ang variable na kailangan na to i-maximize in order for us to get the best viewing angle. So we have tan theta and tan alpha and tan theta. So from these two equations, masolve na pod nato ang equation sa beta. So ang mga vertical distances, given naman siya sa problem. So, ang horizontal distance, which is x, siya na lang ang variable na mabilin. And of course, ang atong beta. Kaya arbitrary pamimitan na itong mga angles. So, the relation of beta with the other two angles is mo ni siya. So, i-substitute na to ang value sa alpha ug theta from these two equations. Mo nang naataan ni. So, from this equation, mo na ni siya itong equation na i-derive. Mo na natatay d beta over dx. So, evaluate na to siya. Then, a series of simplification. Anak ka ni simplification po na siya. Then, I want you to take note of this class. Para ma-maximize o ma-minimize ang kana nga variable, dapat i-equate na to ang iyang derivative with 0. So, nanatay d beta over dx is equal to 0. So, mahulog nga kaning tibok equation is now equal to 0. Para ma-solve na to ang x, ang value sa x. So, namantay isa ka equation with isa ka variable. So, definitely ma-solve na to ang x. And our x is square root of 7 meters. Therefore, the man should stand at a distance of square root of 7 meters from the wall where the painting is hanged or mounted. So, muna siya ang itong final answer. Then, ang ikatulong nga problem involves related rates. So, this time, natay ladder. The ladder is 25 feet long and it leans against a vertical wall. If the lower end is pulled away at a rate of 6 feet per second, assuming na mao ni siya ang lower end which is pulled away, so palayo siya, at 6 feet per second. So, ang question is, how fast is the angle between the ladder and the floor changing? So, muna siya nga angle theta. Para klaro lang. So, how fast is the angle between the ladder and the floor changing when the lower end of the ladder is 7 feet from the wall? So, at a specific position of the ladder, makuha na to ang rate of change sa angle. So, when x daw is 7 feet, or mo na siya ang distance sa lower end from the wall, mo na siya ang specific point in time na kailangan na to ma-figure out or ma-solve ang rate of change sa angle. So, mana siya ang recent class nga ginatawag na to siya nga related change because when this changes, definitely this one will also change. So, mana siya ang motivation sa problem kung ma-slide ang ladder. So, we have to get the rate of change of the angle theta. But first, we need to obtain an equation for theta in terms of x. So, mana siya? Equation of theta in terms of x. So, cosine is equal to adjacent over hypotenuse. Kaya naman na SOHCAHTOA. So, which means sine is equal to opposite over hypotenuse, cosine which means adjacent over hypotenuse, then tangent is equal to opposite over adjacent. So, na natin equation, then we need to isolate the variable theta on one side of the equation. Mo nang magnanatay inverse of cosine or r cosine of x over 25. So, ang rate of change sa theta is its derivative. Isulat na lang nako. So, kailangan na ito pangitaan ng derivative sa equation theta equation. Muna natin d theta over dt. So, importante ng dt class because we're talking about rates. So, change with respect to time. So, i-derive na to siya by usual means. Dali lang man siya. So, karon nga na-derive na to siya. After na to ma-derive, saka na to i-substitute si x is equal to 7 feet. So, ibutan na ko dira, substitute. after derivation. So kana pa lang na time plus na imo siya i-substitute. So basically mo na siya nahitabuan ni nga process. Then makita nimo dari ang final answer, which is negative 1/4 radians per second. So naka-radian siya kay angle man siya nga measure. Radians per second, dili siya kana degrees. So mo na siya ang rate of change sa angle theta. So if one parameter change, other parameters would change as well, depending on what point in time. So muna siya, class. That's all for the recorded lecture para sa inverse trigonometric functions, and I hope that you will ask questions after viewing this. Thank you.